Hey y'all, this video is going to go over graphing sine and cosine. Go ahead and get started with day one. So hopefully looking at this formula you recognize it because we've seen this before when we first talked about transformations. What we're going to do now for unit 4 is we're going to take sine and cosine and turn them into functions and actually graph them. Now to graph them, we do have to explore transformations just like we've done before. The good news on that is the transformations work the same way that they have in the past. So your A value still is a vertical stretch, shrink, and reflection. Your B value is still a horizontal stretch, shrink, and reflection. Your C value is still a left or right move, a horizontal shift. D is up or down, a vertical shift. The only difference now is that we give it different names. So A, our vertical stretch and shrink, will now be called the amplitude. And just to give you a definition for amplitude, go ahead and write this off to the side. Amplitude will be the distance from the from the midpoint of your graph to the highest point. So from the midpoint to the highest point. You'll see what this means in a minute when we start graphing. Horizontal stretch and shrink and reflection we now call the period. Now we did talk about this unit 3. We talked about period a little bit, and hopefully if you remember, one period normally, if nothing has changed, is 2 pi. Now what that means is it takes 2 pi units to complete one entire revolution around the unit circle. And after 2 pi, after one revolution, everything just starts to repeat. Letter C stands for left or right move. That's a horizontal shift. We're going to now call that the phase shift. And D is going to be an up or down move. We're going to call this a vertical slide. So all of these ideas are now the same. We've just given them different names. So now let's go ahead and look onto page 2 where you have these places to put in your sine and cosine parent function. So before we do that, what I want you to do is from the unit circle, based on the unit circle, figure out what your sine values are at 0 radians, at pi over 2, at pi, 3 pi over 2, and 2 pi. Pause the video, go ahead and do that. You should get 0, 1, 0, -1, 0 as your sine values at those angles. So if I go ahead and put those on my graph, 0, 0 is a point, pi over 2, 1 is a point, pi 0 is a point, 3 pi over 2, comma, -1 is a point, and pi over 2 pi, 0 is a point. Now what I want you to notice is that your graph here is actually in terms of radians on the x-axis. Now the reason for that is, think of it this way. If this is your unit circle, what's happened is we've basically taken it apart and we've folded it out completely, we've torn it apart so that it creates a horizontal line. And so if you think about it, all of your angles have now become radians, points on your x-axis. All of your radians belong on the x-axis because we've torn apart the unit circle and we've laid it flat on the x-axis. Your y-axis now represents the values that were in your coordinates. Okay, so now what I want you to notice is that on the unit circle, like we talked last week, on the unit circle, there's actually nothing stopping you. If you were to go and find any radian that you can possibly think of, you can go find the value because there's nothing stopping you in this sense. There's no bound to discovering different radians. Also in the negative direction, there's no bound. So what that tells us is that not only do we have this positive side of the graph, we also have a negative side of the graph, which is very similar. The pattern just continues. So at negative pi over 2, sine would be -1. At negative pi, sine would be 0. At negative 3 pi over 2, sine would be 1. At negative 2 pi, sine would be 0. So what I'm going to do is I'm going to go ahead and really carefully go ahead and draw that sine curve in on the right side because that represents my positive angles. And I'm doing this in a solid line just to emphasize to you that this is actually one period. And because it does repeat, let me go ahead and show that off to this side. And you can do this in a solid line. You don't have to do it in a dashed line, but I just want to show you that this is actually one period and the shape continues. Okay, so like we said, the radians are going to continue. There's no limit on that. So we're actually going to say that the domain for this graph is all real numbers. On my unit circle, like we said, there's nothing stopping me here. However, I do have a limit to how far I can go out to the edge from the origin. So the furthest I can go from the origin is only 1 unit. This is why it's called the unit circle. So really, and if I look at my graph now, the lowest my graph will ever go is -1. The highest it will go is +1. So it relates directly back from your unit circle to the graph. Amplitude is, again, the distance between your midpoint, which is 0, to the highest point, which is 1. So the amplitude here is simply 1. Also in your equation, your amplitude would be the first number that you see in front of the function. Okay, the period is 2 pi because, like we said, it takes 2 pi to finish one revolution, and in this case, it takes 2 pi to finish one pattern before it starts to repeat again. Because if I were to show you what happens here, it's just going to go back up and then back down. So it takes 2 pi to finish one pattern. So that's a sine graph. Now for cosine, it's the same idea. I know my domain, again, is all real numbers because there's nothing stopping the radians. The range will also be -1 to 1 here as well. Amplitude, again, is 1. Period is 2 pi. Now to graph this, it's going to be a tad bit different, but I want you to go ahead and actually find the cos values now, because we're working with the cos function. Find the cos values at these radians. So pause the video, go ahead and do that. You should get 1, 0, -1, 0, and 1. If I put that on my graph, my points will be right over here. And once I connect them, that's what it will look like. Now again, if I continue on to the left side, at -pi/2, my point will be at 0. At -pi, -1. At -3pi/2, 0. At -2 pi, +1. So let me go ahead and show you what that would look like. But notice that the pattern does repeat. Okay, and if I were to show you this side in case you're curious, it does continue that way. Sine and cosine curves are basically like a wave that never ends. So now what we're going to do is we're going to take these parent graphs and we're going to transform them. So on page 3, you have, for the first 2 problems, you have amplitude changes. Now remember, that's the distance from the midpoint to the highest point on your graph. And that number will be located right over here. So I'm going to do number 2 for you. Number 2 actually has 2 transformations to take care of. The first thing is the vertical reflection over the x-axis. And the second transformation is your vertical shrink by 1/2. So I have to notice, first of all, that this is a cosine function, and if I take a look at my cosine parent graph, my parent points, I know that it starts at 1, goes to 2, and then to -1, then back to 0, and to 1. So here's my first point right over here at 0, or I'm sorry, at +1. I know that I have to do a vertical reflection, so I know that's going to go to -1. And after my shrink, my point should be at 0, -1/2. Pi/2, my point is normally at 0. And after I do vertical reflection and a shrink, it's actually not going to go anywhere, so that point's going to stay put. At pi, my point is normally at -1. After my reflection, it's going to go to 1. After the shrink, it'll go to 1/2. 3 pi over 2 is normally at 0, so I know that's not going to go anywhere. 2 pi is normally at 1. After my vertical reflection, it's going to go to -1. After the vertical shrink, at 1/2. So if I carefully go ahead and connect those dots, there's a graph that I should have, and it does continue very similarly on the left side. Just like that. So again, my domain is all real numbers. My amplitude, remember, is the distance. Now, distance can never be negative. So even though we have a reflection, we cannot write down a negative in the amplitude. We must write positive 1/2 because, again, it's the distance between your midpoint and the highest point there. Phase shift, I don't have. Remember, that's a left or right move. My range, I know, is from -1, -1/2, I'm sorry, to positive 1/2. The period is still 2 pi. Vertical slide, I don't have. Okay, number 2 on the bottom section, this is now a vertical slide or a vertical change. So now we have, again, 2 things here to do as well. We have, the first thing we'll do is a vertical stretch by 2. And then the next thing we'll have to do is go down 3.5, or you can call that 1.5 if it makes you feel better. So it is a cosine curve, so I know cosine starts at 0, 1. Vertical stretch by 2 will take that point to 2. And then down by 1.5, we'll take it down to 0.5, 2.5. Okay. My next point for cosine is normally at 0. Vertical stretch by 2 won't take it anywhere, but down 1.5 will actually take it down to -1.5 or -1.5. At pi, my point is normally at -1. A vertical stretch by 2 will take it to -2, and down by 1.5 will take it to -3.5. Pi over 2, or 3 pi over 2, I'm sorry, is normally at 0. I can only go down 1.5, so there you go. 2 pi is normally at 1. A vertical stretch by 2 will take it to 2. Down 1.5 will take it to positive 1/2. And if I go ahead and connect those dots, this is a curve that I get, and it does, again, repeat on the left side. Just like so. Be very careful. Just like that. So I know my domain is all real numbers. My range is from -3.5 to positive 1.5. The amplitude, again, it's the distance from the midpoint to the highest point. And if you take a look right here too, it is simply 2. Period is 2 pi. Phase shift, I don't have any left or right moves. Vertical slide, I do have. It's down 1.5 or down 3.5. Okay, on page 4, you have phase shifts. I'm going to do numbers 3 and 4 because I think 1 and 2 are a little bit simpler. But number 3, you have a sine function, and you have theta minus pi over 6. Now remember, phase shift is a left or right move. Now instead of a whole number, like you normally have in monster functions, you normally have a whole number left or right move. But now, because we're working with radians and your x-axis is full of radians and nothing else, it only makes sense to have a phase shift in terms of pi. So if I look at number 3, it says move to the right pi over 6. Now, pi over 6 may seem kind of challenging. However, what I want you to notice is that on your x-axis, pi over 2 is 3 marks over. Pi over 2 is 90 degrees. What that means is that every single mark is actually 30-degree increments. And since we're not talking degrees, we're talking radians, that means 30 degrees. So pi over 6 is really is what each mark represents. So every single mark is pi over 6. 30 degrees. So my phase shift is to go to the right pi over 6, which really means just right 1 mark. I have a vertical slide to go up 2, and let me fill out whatever else I can. So I know the period is 2 pi. The amplitude is technically 1. Domain I know will be all real numbers. And we'll come back to the range. So I know my sine function starts at 0, 0, but I need to go to the right pi over 6 with that point and take that point also up 2. So there's my new point. For the sine function, pi over 2 is normally at 1. I need to go to the right pi over 6, so that's only right 1 mark, and then up 1, 2. Pi is normally at 0. I'm going to go to the right pi over 6, right 1 mark, and up 1, 2. 3 pi over 2 is normally at negative 1. I'm going to go to the right 1 mark, 1 pi over 6, and up 1, 2. And 2 pi, oops, oh, that's right. At 2 pi, I normally have a point at 0. I'm going to go to the right pi over 6, that's 1 mark, and up 1, 2. So 1 period of this function is right over there. And so I know now that the range goes from 1 to 3. And there you go. Number 4, I have 2 things to do there as well. Now I'm going to go ahead and actually do the inside first, just like we've talked about in the past. So I will go ahead and move to the left pi units, and then I'm going to do a vertical stretch by 3. So I know already that my amplitude is 3. I know my period has not changed, it's 2 pi. I know the domain has not changed, it's all real numbers. I have a phase shift of left pi units, and I don't have a vertical slide. So, and also notice this is a cos function, and I know cos starts at 0, 1. So I'm going to go to the left. I'm going to take that point and go to the left pi units. Now, pi units is 6 marks, so it's all the way out here. Now I'm going to I actually need to also go and do a vertical stretch by 3, so that point is actually going to go here to 3, not there. Okay, my next point would normally be at pi over 2, 0. I need to take that point to the left pi units. Now, you have to be careful, because if pi over 2 is only 3 marks, then I know another pi over 2 will get me to pi, a whole pi units. That's 6 marks. So that's left pi. Now, stretch by 3 won't take it anywhere, so there we go. My next point would be at pi, negative 1. Left pi units will actually take it to 0, negative 1, and then vertical stretch by 3 will take it to negative 3. Okay? If I follow that same pattern, you should end up with a graph that looks like this. And of course, you want to show that it does continue on either side. Just like that, and there you go. Domain, I know it's from negative 3 to positive 3, where my amplitude is simply 3. Okay. Now we're going to talk about day 4. So now day 4,